everyone. We will discuss the Module 9, which is the Statistical Process Control. So, before anything else, we would like, what I would like to define first the Statistical Process Control. So, Statistical Process Control, also known as SPC, is a method of measuring and controlling quality by monitoring the manufacturing process. So, quality data is collected in a form of product or process measurements or reading process various machines or instrumentations. So, the data is collected and used to evaluate, monitor, and control a process. So, statistical process control is an effective method to drive continuous improvement. By monitoring and controlling a process, we can assure that it operates at its fullest potential. So, one of the most comprehensive and valuable resources of information regarding SPC or Statistical Process Control is the manual published by Automotive Industry Action Group or AIAG.
The history of the statistical process control. It may surprise you to know that statistical process control has been around for almost a century. In 1924, Dr. William Shewhart of Bell Laboratories researched methods of improving manufacturing quality and lowering costs, which laid the groundwork for SPC. He created a control chart to determine whether a process was in or out of control. He published a book, Statistical Method from the Viewpoint of Quality Control, in 1939. The U.S. military relied heavily on SPC during the Second World War to oversee product quality in weapons and munitions without sacrificing safety. Unfortunately, SPC fell out of practice when the war ended. After the war, Dr. Edwards Debye refined and updated Shewhart's work and brought it to Japan, where Japanese businesses enthusiastically embraced the ideas. SPC helped Japan recover its manufacturing capability and even exceed it, giving the Japanese a World War reputation for industrial excellence. Finally, in the 1970s, the United States, feeling the pressure of the competition stemming from Japan's high-quality manufactured goods, began to adopt SPC. Today, statistical process control can be found all over the world.
Manufacturing companies today are facing ever-increasing competition. At the same time, raw material costs continue to increase. Many companies still rely on only inspection after production to detect quality issues. The SPC process implemented to move a company from detection-based to prevention-based quality controls. By monitoring the performance of process in real time, the operator can detect trends or changes in the process before they result in non-conforming product and scrap.
Let's discuss the objectives of statistical process control. So, statistical process control's chief objective is improving process by reducing unwanted and unexpected variables. So, when an organization uses SPC to meet that goal, that helps achieve other related business goals like first is increasing customer satisfactions while decreasing customer complaints. Next one is reducing or eliminating the need for supply chain inspection. Next one is establishing a consistent and predictable level of quality. Next one is decreasing cost related to scrap materials, reworking, and inspections. Next one is increasing machine operator motivation and morale. Next is increasing efficiency of data entry, analysis, and reporting. Next is improving communications among all levels in organizations. Second to the last is increasing overall productivity, and last is reducing investments in infrastructure because process improvements make existing infrastructure for efficient. Okay, let's talk about the statistical process control example. So, as commonly known, variation is a natural phenomenon. Due to this, it is impossible to create a process that is free of all variability. So, it is possible to monitor and control the amount of variation in a process so that it remains within acceptable limits. This is where statistical process control comes in. SPC uses statistical method to monitor process variation and identify when it is outside of acceptable limits. So when, when this happens, corrective actions can be taken to bring the process back into control. So one of the most common tools uses in SPC is the control chart. So control charts are graphical representations of process data that are used to identify special cost variation. So control chart typically include three types of information, which is the data that was collected, a central line that represents the mean and or average of the data. Next one is upper and lower control limit that represent the acceptable limits of variation. So, uh, control charts are used to determine if a process is in statistical control. So, this means that the process is operating as it should, and that the variation represent a percent is due to common causes. When a process is in statistical control, it is said to be predictable and stable. This predictability means that the process can be relied upon to produce consistent results within the acceptable limits of variation. Suppose that a company is monitoring the weight of product coming off an assembly line. They collect data for 100 products and create a control chart. The data shows that the average weight of, of the product is highly below the desired weight, and that the variation is within the acceptable limits. Based on this, the company can conclude that the process is in statistical control and is predictable. Now, assume that the same company collected data for 100 products a year later and found that the average weight was significantly below and desired weight. So, in addition, the control charts showed that the variation was outside of the acceptable limits. So, um, this would indicate that the process is not in statistical control and is not predictable. So, in this case, the company would need to take corrective actions to bring the process back into control. So, there are many different types of control chart that can be used to monitor different types of data. So the type of control chart that is used will depend on the type of data being collected and the process being monitored. Some common types of control charts include X bar chart, R X bar chart, and R charts. So these charts are used to monitor continuous data that can be measured on a scale. Example of this type of data includes length, wind, temperature, and so on. Next one is P chart. These charts are used to monitor proportions or percentage. So they are typically used to monitor the number of defects in a process. And the third one is NP charts. So these charts are similar to uh, P charts, but are used to monitor the number of non-conforming units in a process. And last is C charts. So these charts are used to monitor the number of events that occur in a process. So example of events include the number of defects, accidents, and so on.
Statistical Process Control Tools Overview. There are 14 quality control tools used in statistical process control, broken down into 7 quality control tools and 7 supplemental tools. They are quality control tools, cause and effect diagrams, also called an Ishikawa diagram or fishbone diagram. Cause and effect diagrams identify multiple causes of a problem. The diagrams use a fishbone structure and each branch represents a problem category. Check sheets. Check sheets are simple, preferred forms used to illustrate collected data and analyze it. These sheets work well with data that can be repeatedly observed and collected by either the same person or in the same location. Control charts. Control charts are the oldest and most popular SPC tool. They aid in recording data and spotting unusual events, particularly when compared to typical process performances. The charts distinguish between two types of process variation, common cause and special cause. Histograms. Histograms are graphs that show frequency distributions and often resemble a bar chart. They work best when most of the data is number form. Pareto charts. Pareto charts are bar graphs that represent time or money, or alternately frequency or cost. They are especially useful for measuring problem frequency. Scatter diagrams. It is also known as an XY graph, scatter diagrams graph. Pairs of number data and one variable assigned to each axis. Scatter diagrams work best with fair numerical data. Stratification. These tools separates data to make patterns easier to identify. Stratification is the process of sorting objects, people, and data into layers or distinct groups. It is ideal for data that comes from different sources. Supplemental tools. Data satisfaction. A variation of the stratification tool mentioned above. Defect maps. These maps help visualize and track a product's effects, identifying the physical location and types of loss. Each found defect is identified on a map. Event logs. Event logs are a centralized, standardized means of recording important software and hardware events. Process flowcharts. Process flowcharts are pictures of a process steps displayed in sequential order. Progress centers. Progress centers are centralized locations that monitor progress and decisions are made based on the data collected. Randomization. Randomization uses chance to assign the units in question across a collection of treatment groups. Sample size determination. These tools involve determining the number of individuals or events to include in creating a statistical analysis.
Statistical Process Control Application. The right software makes it easy to implement SPC practices. There are many products to choose from, tailor-made to suit the requirements of any business, regardless of size, industry, or type. Here are 4 examples. First is GACE or GACE. It provides business management software for small and mid-sized businesses. It includes modules for accounting, customer relationship management, enterprise resource planning, inventory management, order management, and production management. Next is Katana. Katana is a popular manufacturing and inventory software application that ideals for scaling businesses. It provides seamless integration with QuickBooks, Shopify, WooCommerce, Xero, to name a few. Third is Genius ERP. Genius ERP provides custom manufacturer tools needed to increase productivity, reduce costs, and improve production site performance. It works best with small and mid-sized custom manufacturers in the US and Canada. Genius ERP consists of centralized system that includes variable tools such as account management, CRM, inventory management, product engineering, job costing, scheduling, and production planning. Lastly is InfoVisual. InfoVisual provides application for managing MRP, MES, supply chains, reporting, and customer management. It works best for manufacturing in the automotive, aerospace, electronics, industrial equipment, and medical device industries.
How to implement SPC charts? SPC charts requires organization's commitment across functional boundaries. So here is a step-by-step process on how you can construct um, an effective SPC charts. So we have 4 steps. So for the first step, determine an appropriate measurement method. Um, you know, the first step is to decide what type of data to collect, variables or attribute. It is highly advisable to use variable data wherever possible as it provides a higher quality of information. So once you decide what type of data to collect, you can then choose the appropriate control chart for your data. So step 2 is determine the time period for collecting a plotting data and determine the time period for collecting and plotting data. So because SPC charts measures the changes in the data over time, it is necessary um, that you maintain a frequency and time period to collect and plot the data. Like for example, making an SPC chart every day or every other week can help you see whether your process is reliable and improving constantly, or whether you will be able to meet a quality standard in time. So uh, next, step 3, establish control units. So the next step is creating an SPC charts. It is SPC charts is to establish the control units. So here uh, how you can calculate the control units. So first is estimate the standard deviations uh, of the sample data. So to calculate UCL, you need you need the formula. So UCL equals to average plus 3 times the standard deviation. Next one is to calculate LCL. So LCL is equals to average minus 3 multiply the standard deviation. So next is step 4. Plot data points and identify out of control data points. You know, after establishing control limits, the next step is to plot the data points on the SPC charts. So once you have plotted the data points, you can construct to see um, in them, yun, is to see in them. So recognizing this pattern is to um, is the key to finding the root cause of special causes. So some of these patterns depend on certain zones.
The three types of control chart in SPC. If you have already made a decision to embrace a statistical process control SPC method, such as a control chart, which can visually track processes and abnormalities, you are already well on your way to bringing manufacturing quality control to your operations. So what's the next step? Determining which type of control chart to use. That decision is based on the style of the data stream that you would like to be presented. Steve Weiss, Vice President of Statistical Methods for Infinitec US says, trained statisticians will know when they walk up to a data stream what core control chart they should start with. But the first step is to ask yourself what decisions you want to make from this chart. That will help you to dictate the chart type and sampling strategies. Control charts typically fall into three categories. Let's take a quick look at the different types of control charts here. For a deeper dive, visit our definitive guide to SPC charts. Number 1 is the X-bar and range chart. The most common type of SPC chart for operators searching for statistical process control. Control charts typically fall into three categories. Let's take a quick look at the different types of control charts here. For a deeper dive, visit our definitive guide to SPC charts. The number 1 is X-bar and range chart. The most common type of SPC chart for operators searching for statistical process control. The X-bar and range chart is used to monitor a variable's data when samples are collected at regular intervals. The chart is particularly advantageous when your sample size is relatively small and constant. Number 2 is the individual X moving range chart. When it doesn't make sense to take multiple readings, the individual X moving range chart is the ideal option. This is particular SPC chart is used to monitor variables data when it is impractical to use rational subgroups. When data is very expensive or there is a whole lot of time between samples, the concept of X-bar and range makes no sense. Weiss explained, it is better to go with individual X moving range. And the last one, X-bar and standard deviation chart. This chart is primarily used to show how much variation and dispersion exists from the average of our expected value. The X-bar and standard deviation chart is touted for helping manufacturers, engineers, and operators understand variation better.
SPC is important to you because you want to give your customer good quality products and services. Inspection cannot build quality into a product or a service. The process producing it needs to be capable to deliver good quality. Quality is this built into a product or service through process assurance. SPC brings you a well-defined method of assuring quality of a process and monitoring the stability of a good process over a period of time. SPC helps you bring about process assurance and in turn a good quality in what you do.
Let's now talk about the benefits of statistical process control. Whatever type of business you are operating, it's imperative to avoid business challenges before they hit you. Luckily, there are several methods for companies to apply that drastically improve quality manufacturing. One strategy is statistical process control, or SPC. SPC is a scientific data-driven techniques used in the production and manufacturing process to ensure consistent performance according to its stated design. SPC is used for several purposes. It can be highly advantageous for the production and manufacturing industries for many reasons. SPC is everywhere in manufacturing because it works. Manufacturers are only as good as the processes they use. They are judged by the quality of products they make. But there are struggles. SPC helps reduce scraps, waste, defects, and rework, improve product quality, eliminate variations in processes, and maintain compliance with regulatory and customer requirements. First is reduce waste. defects, and rework. A key benefit of SPC software is uniformity. SPC helps the operator detect and correct errors before they cause significant problems in manufacturing processes and product. The software guarantees excellent uniformity of the end product irrespective of any number of units produced in a day. These characteristics help minimize the need for a product rework or other extra product expenditures to fix an offering. Second is improved product quality. Without SPC software, it is difficult to identify a problem throughout the manufacturing process. With SPC, manufacturers can catch all implementation defects during the manufacturing process. Doing so will avoid frequent shutdowns and facilitate a continuous workflow. The whole production process is not entirely shut down, maintaining a constant process. Once the process is ongoing, productivity is maximized. Third is eliminate variation in processes. The statistical process control possesses charts that display all statistical data for monitoring production efficiency in a graphical format. The software detects and shows any unnecessary process variation so that producer can examine for difference cases. The statistical data gives immediate analysis to set a reference point for manufacturing, improve the manufacturing process, point out imperfection, and make them right without assumption or guesswork. Fourth is maintain compliance with regulatory and customer requirements. Every business is aimed at meeting the needs of the customer and becoming a long-term supplier to the buyer. For example, a vehicle manufacturer depends on its part provider for guaranteed quality spare parts at a friendly price. Using the statistical process control software, the supplier is particular customer loyalty since the producer can rely on the good quality product. Lastly is control and reduce costs. Statistical process control is a powerful tool for controlling production costs. SPC keeps an eye on the quality of products. Imperfections are identified before the product delivery. A good example is that a car producer can incur a significant loss by reworking a car or fixing a defect. If SPC is used effectively, the defects can be traced before the end product is delivered, reducing rework costs. Apart from the above detailed SPC benefits, SPC software also offers other significant benefits for your batches together with improved analytics and reporting, reduced software training, maximize capacity to answer new opportunities, the cost of upcoming innovation vividly reduced, intuitive system interfaces, customizable open source code, decreased IT software support necessity. Customers are in pursuit of quality products. The biggest challenge for manufacturers is to maintain the desired quality, improve your overall business operational efficiency by using statistical process software for increased productivity. It programs information and analysis on the production floor, helping you eliminate defects before they appear.